All right, so today we're gonna do lead code question number 22. Generate generate parentheses. So this is a medium questions, and the question is asking that given n pairs of parentheses, write a function to generate all combination of well-formed parentheses. Right. So the inputs. So as we can see here, the input is going to be n and output is going to be parentheses with different forms, right? You can see that there, like if n here is equal to 3, then we can see that there are three pair of parentheses um, inside one string, right? So here it is simply as one. And then you can see here open brackets, right? Two open brackets and close one, and one open brackets. So that's going to be a total of three, and that's going to be close. So it's going to be total three parentheses, right? So the trick of these questions, right? So is that we need to understand first, right? Like that the first thing that the data structure that we can use is that we can use a stack, and then we can also use a backtracking method to do this. All right, I'm gonna put this on iPad to show you the screen is equal to 3, right? So this means that there are a total max um, parentheses of 3 pair, right? So obviously there must be some three conditions. There must be three conditions that need to follow this rules, right? In order for this parenthesis to work, is that the left parenthesis has to always be before right parenthesis, right? So that's rule number one, right? So yeah, why? Because let's say if you have the right parenthesis, right, and then followed by the left parenthesis, and then here we can see that the whole string is going to be invalid, right? So that's rule number one, right? And the rule number two is going to be the left parenthesis, the number of left parenthesis has to be less or equal to number of n, right? So this is really logic because um, if the number of n is given, the number of left parentheses has to be lesser than or equal to number 3, right? And the third one is that the number of right parentheses has to be lesser than left parentheses. Why? Because as I can tell you, let's say if we have this rule, let's say if like we have two left parentheses and then the right parentheses, right, to cover, and then if we add one more right parentheses, then this whole thing is going to be invalid, right? Because the right parenthesis is more than the left parenthesis. So that's why here the third rule has to come into the play because there is that the number of right parentheses has to be less than the left number of parentheses. Okay, so once we know these rules, right, we can draw out a binary problems. So this is more like a binary problem. Why? Because there are two choices, right? So the first choice here is going to be empty, right? The stack is going to be empty, right? So the first choice that we can make is that we can put the left parenthesis first, right? And then there are two choices after that. So what are the two choices? The the next choice that you can put another left parenthesis. Okay. So, also, I need to mention that okay, this is like for the case that n equal to 3, right? Okay, continue with the parenthesis. So here the choice that you can put the left parenthesis one more and become like this, or we can have like the right parenthesis and close brackets, right? So that's going to be one complete, right? And then another choice, and then we can continue with this on the left side is that we can put another left parenthesis because the max is 3, so that's the max. Or you can put close parenthesis like this, right? And for this one, it's gonna be the same. It's gonna be like this, right? But then you can't do this, right? Because it's gonna break the rule. So that will not be included. Here we can do okay. So if we continue, we're gonna get this, right? And then we're gonna get um, this and this, or this and this and this, right? And here it's going to be the same. It's going to be 1, 2, like this, or you can put 1, 2, 3 like this, right? And all right, so if we continue with this, right? And then sorry, I think I get lost in my train of thoughts. Okay, and right, so if we continue with like here, there's only one option left. Is that only to put right parentheses, right? Because why? Because the left parenthesis is already at the maximum at the 3, right? So here we're gonna start closing the brackets, right? And next one is gonna be like this, right? So here we can complete the three set of parentheses, right? So once we do that, we can go back here and continue with this, right? And that's gonna be like this, here like this, and then put like this. All right. So if we continue this work, right, we're gonna get all the possible pair, like all the possible combinations of three sets of parentheses, right? Um, right here, right? Okay. All right, so here we get all the possibilities, right? And the way how the code is going to work is that it's going to use recursion with the backtracking process, right? So the step one is going to be here like this, right? So once finished, right, it's going to return this and it's going to append this into the rest, right? And then it's going to go back to here and pop one of that, and then it's going to go into this decision making branch, and then it's going to go in this way, and it's going to reset and it's come back here again, and go on, so on and so forth, right, until we get all the possible combination of the parentheses. All right, so now that we understand the solution part, right, now let's get back to the coding part. All right, okay. um, this might be a little bit confusing for someone who never experienced backtracking or recursion before, but let's see. Okay, here, so definitely, so we need to return a list, right? So I'm going to create an empty array, and here I'm going to create a stack, right? So after that, right, I'm going to create a nested function inside the solution class, right? So I'm going to call it backtrack, right? So and the and the input parameters is going to be the left parenthesis, right? So this is going to indicate how many parentheses there are inside of the backtracking. No, it's how many parentheses there are inside as an arguments, right? So that's going to be integer, right? And here is going to be the right p, and here int, right? And then all right, okay. So do remember the first three basics principle, right? That we need to understand is that for this case, I'm going to rewrite again for just for you to see. Is that the first one is that the base case for recursion, right? Um, the left pointer, the left parenthesis must be equal to the right parenthesis, and then it has to be equal to the number of n, right? So in this case, it's going to be the base case, and this is where the recursion, right, meets the dead end, right? Right, and then and 2 is that the left parenthesis must be must always be more than must be always be less than n, right? Less or equal to n, less than n. And 3 is that the right parenthesis must always be less than left parenthesis. Okay. So we're gonna continue with that. So we're gonna start with the first with the first if condition. Is that the base case, right? So we can say that if left parenthesis is equal to right parenthesis and equal to n, then we want to combine. Then we want to append that to the rest, right? So we want to append that to the rest. So it's going to be stack as append this function join to join all the items inside the stack, right? To combine them, and then we can join stack. All right. So because imagine like once we imagine like the example of the stack is going to be something like this, right? It's going to be open parentheses, and example is going to be like this, right? So you probably want to combine them together to become like this, right? And then and here you can actually use join methods to do that, and after that you want to return, okay, and the if condition, like if left parenthesis is less than n, so we want to push stack dot append. We want to push that into the stack with the left parenthesis, right? And then we want to recall the backtrack function again, but this time since we add one parenthesis here already, like since we have one left parenthesis, so we need to indicate that we want to like that the left parenthesis is more, so we plus 1 here, and then we insert the same number of the right parenthesis. All right, and after that, and then it's going to recall these functions again, right? But then we need to think about like after the recursion ends, we need to pop the stack, right? We need to pop the latest one on the pop top element of the stack, right? Okay, and after that we want to do if right parenthesis less than left parenthesis, right? So following these conditions, right? And we want to do the same, but here stack pen, right? And that's going to be close brackets, and that is going to plus 1, right? And after that, and so that's it for the for the backtracking methods, right? So that should produce the combination of parentheses like here as like the outputs, and okay, and after that, I probably want to call this method a backtrack starting from 0 and 0, because at first we don't have any left parentheses and right parentheses, and here after that we just want to return rest. I think that would be it. All right, let's see if I get my answers correctly. Let me check the mistake before I make submissions. Okay, that looks okay, and that looks okay, and that looks okay. Okay, right, 2, 5. Okay, that's it. I am gonna click submit and see if it goes smoothly. All right. It seems like I get correct solutions. All right. Okay. So yeah, it works, right? So the key to remember this is that we need to understand these 3 points, 3 key points before we code on the solution, and we can and also that we can create another function as a backtracking, like for the backtracking methods, right? And yeah, um, that would be it, right? Thanks for listening.